All right, welcome back everyone to the deep dive. You know, we're always talking about these large language models and AI and how they're getting so good at answering our questions, right?
Oh, yeah.
But what about when we ask those really complex questions that require digging up and piecing together new information and maybe connecting some dots that
Yeah.
the AI hasn't seen before?
Right. Yeah. Like stuff that isn't just a quick fact, but needs a deeper understanding of, multiple sources or even things that are changing all the time.
Exactly.
Yeah.
That's the challenge we're going to be tackling in this deep dive. We're going to be looking at a new approach called R1 Searcher that's aimed at helping these LLMs become even better researchers.
hmm
Sort of like giving them the ability to hit the books, do their own homework, and come back with more reliable, accurate answers.
It's like, those times when you ask an AI something and it gives you an answer that's kind of convincing, but then you do a little digging yourself and realize, it's not quite right.
Yeah, exactly. Those AI hallucinations, as they call
Yeah.
them. So for this deep dive, we've been going through a research paper titled R1 Searcher, Incentivizing the Search Capability in LLMs via Reinforcement Learning. And it gets pretty deep into how they're using this technique called reinforcement learning to really teach these models how to search effectively.
Yeah, and what's really interesting is that they're not just giving the LLM access to a search engine and saying, okay, go find the answer. They're actually training it to independently decide when to search, how to form those search queries, and then how to actually use the information it finds to reason through and answer those complex questions.
It's like they're training it to be a real detective,
Yeah.
like figuring out what clues to look for, not just getting handed a case file and told, here you go, solve this.
Exactly, yeah.
Okay, so let's start by talking about the problem a little more. Why do current LLMs sometimes struggle with these knowledge-intensive questions? What are the limitations of relying solely on their internal knowledge base?
Well, I think the biggest issue is that the knowledge they have is, well, kind of frozen in time.
Like a snapshot of whatever they were trained on.
Right, exactly. And so if you ask them about something that's really new or maybe very specific to a niche topic or something that's constantly changing, they might not have that up-to-date information.
So it's not that they're not smart, it's just that their knowledge can be outdated.
Yeah, exactly. And then there's also the problem of connecting the dots.
Meaning,
Well, sometimes a complex question requires pulling together information from lots of different places and then figuring out how those pieces relate to each other.
right, that synthesis process.
Yeah, exactly. And that's something that current LLMs, especially those that just rely on their internal knowledge, can struggle with. They might have all the pieces of the puzzle, but they might not know how to put them together correctly.
Okay, so that sets the stage for this idea of augmenting LLMs with external knowledge sources.
Yeah.
And that brings us to what we call retrieval-augmented generation, or ANR-AG.
Yeah, REG is basically about giving LLMs access to external information sources like search engines or databases so they can go out and get the knowledge they need to answer those tough questions.
So like giving them a research library.
Exactly, yeah. And there have been a lot of different approaches to RAG over the
Oh,
years.
really? Like what?
Well, initially, a lot of the focus was on crafting really clever prompts to guide the LLM in its search.
So prompting engineering, getting really specific about how you phrase the question to kind of nudge the LLM in the right direction.
Yeah, exactly. Like you might break down a complex question into smaller steps, tell the LLM to come up with specific search terms, and then instruct it to use the results to generate an answer.
And that work okay?
It could be helpful, but it often relied on really powerful LLMs, those really big, sophisticated models.
So not ideal for smaller models or those that are more resource constrained.
Right. Yeah. And there was also the issue that these prompting strategies were very specific to the particular question. So they didn't necessarily generalize well to new questions or new topics.
So not a very flexible solution.
Right. And then another approach was to use supervised fine-tuning to try to teach smaller models these search skills.
So instead of giving them specific instructions for each question, you'd show them lots of examples of how a bigger, more powerful model would search and answer questions.
Yeah, exactly. Like you'd show them a bunch of question-answer pairs along with the search queries and retrieved documents that the bigger model used, and the smaller model would try to learn from that.
But wouldn't that just lead to memorization? Like the smaller model might learn to mimic the specific patterns in the examples, but not really understand the underlying principles of effective searching.
Yeah, that was a concern. And the research suggests that this type of supervised fine-tuning could lead to models that were good at specific tasks, but struggled to generalize to new situations.
So not quite the adaptable independent researchers we're aiming for.
Right. There were also some attempts to scale up the search process itself when answering a question.
Like, instead of just doing one search and getting a few documents, you'd explore lots of different reasoning and search paths, almost like trying out different routes to get to a destination.
Exactly, yeah. And one way to do that is through something called Monte Carlo tree search, where you basically explore a bunch of different possibilities and then choose the one that seems most promising.
But wouldn't that get really computationally expensive? Like, wouldn't it take a lot of time and resources to explore all those possibilities?
Yeah, that was the downside. It could make the answering process really slow and inefficient, which is not ideal for real-world applications.
Okay, so we've got these prompting strategies that could be too rigid, supervised fine-tuning that might just lead to memorization, and then these scaled-up search processes that can get really slow. That sets the stage for R1 Searcher. So what's the core idea behind this new method? How does it actually incentivize the LLM to become a better, more independent researcher?
Well, the key is that R1 Searcher uses reinforcement learning, or RL, to teach the LLM how to search effectively during the learning process itself.
So it's not just about using search to answer questions. It's about learning how to search effectively as part of the learning process.
Exactly, yeah. And the way they do this is through a two-stage outcome-based RL approach.
Okay, two stages, outcome-based. Let's break that down.
All right, so the two-stage part means that the training process is divided into two distinct phases, each with its own specific goals and reward system.
And the outcome-based part means that the model learns based on whether it ultimately gets the right answer or not, rather than on being told exactly how to search.
Right, exactly. So it's like giving the LLM a puzzle and saying, here, figure out how to solve it.
Okay.
And then it gets rewarded based on whether it puts the pieces together correctly.
Okay, that makes sense. So let's start with stage one. What's the focus of this first stage's training?
Stage one is all about teaching the model the basic mechanics of using an external search system.
Like the nuts and bolts of how to form a search query, when to initiate a search, and how to integrate the results back into its reasoning process.
Exactly, yeah. And they call this stage retrieve reward because the main reward the model gets is for simply using the search system at least once during its attempt to answer a question.
So it gets a little reward for being curious and exploring the external knowledge base.
Exactly, like a little treat for being a good researcher. And if it doesn't use the search system at all, it gets no reward for that attempt.
So there's a clear incentive to actually go out and do some research.
Yeah, exactly. And they also reward the model for getting the format of its output right.
Meaning?
So they want to make sure the model is clearly separating its own thoughts from the information it retrieves, that it's providing a concise answer rather than just dumping a bunch of text, and that it's not trying to directly copy documents without actually searching.
So it's about learning to present its findings in a clear and structured way.
Right, yeah. And importantly, in this first stage, they're not even looking at whether the final answer is correct. It's all about learning the proper way to search and present information.
Like learning the rules of the game before actually trying to win.
Exactly, yeah.
Okay, so stage one is all about learning the mechanics of research. What about stage two? How does that build on what the model learned in the first stage?
All right, so in stage two, the focus shifts to actually using those search skills to answer questions correctly. And this stage is called answer reward, because now the model is rewarded based on the accuracy of its final answer.
Well, now it's not enough to just search. It actually has to find the right information and synthesize it into a correct answer.
Exactly, yeah. The reward for just searching is taken away in this stage, and the reward for getting the format right is still there, but now there's a penalty for getting it wrong.
So like a little discouragement for bad formatting.
Yeah, exactly. But the big change in this stage is the introduction of this answer reward, which is based on how well the model's answer matches the actual correct answer.
And they use this metric called the F1 score to measure that match, right? Can you explain that a bit more? I know we touched on it briefly, but I think it's worth digging into a little more.
Sure, so the F1 score is basically a way to balance two important aspects of answering a question correctly. Getting all the relevant information and not including any irrelevant information.
So it's not just about being right. It's about being right in a complete and concise way.
Exactly. So if you think of the correct information as being like red balls and the irrelevant information as being like blue balls, the F1 score measures how good you are at catching all the red balls and only the red balls.
So not catching too many blue balls means being precise, And catching most of the red balls means being comprehensive.
Right, yeah. And the F1 score gives you a single number that balances those two aspects. So a higher F1 score means the model is doing a better job of providing a complete and accurate answer.
Okay, that makes sense. So in stage 2, the model is essentially learning to refine its research skills to maximize its F1 score.
Exactly, yeah. And this whole two-stage approach is designed to work solely with outcome-based RL, meaning the model isn't given any specific instructions on how to search or what the correct answers are.
It's just thrown into the deep end and told, figure it out.
Pretty much, yeah. It learns by trying things out, getting feedback in the form of rewards and penalties, and then adjusting its behavior based on that feedback.
So it's like a self-guided learning process.
Exactly, yeah.
Okay, so we've got the 2 stages of training,
Mm.
but how does this all actually play out? Like, how does the model interact with this external search system during the learning process? Does it just stop what it's doing, go off and do a search, and then come back?
Well, they had to come up with a clever way to integrate the search process into the model's thinking. So they implemented this technique where the LLM uses special tags to signal when it wants to perform a search.
Like little markers in the text that say, hey, I need to look something up.
Exactly, yeah. They use these tags, like begin of query and end of query, to enclose the search query. And then when the model generates the end of query tag, the training process pauses, takes that query, and uses it to search for relevant documents.
So it's like the model is saying, hold on a second, I need to Google this.
Yeah, exactly. And then those retrieved documents are fed back into the model's thought process, also enclosed in specific tags so it knows this is external information.
So it's like the model is saying, okay, I've got some new information now. Let's see how this fits into my answer.
Right, exactly. And to make sure the model is actually understanding and using the information it finds rather than just copying and pasting, they also do this thing called retrieval mask-based loss calculation.
Okay, that sounds complicated. What's that all about?
Basically, during training, when the model gets those search results back, they kind of hide the exact words of those results while it's figuring out how to incorporate them into its answer.
So it's like giving the model a summary of the information without showing it the actual source material.
Yeah, something like that. And this forces the model to actually understand the gist of the retrieved information and figure out how it relates to the question rather than just memorizing and repeating specific phrases.
That's clever. It's like making sure the model is actually doing the intellectual work, not just taking shortcuts.
Exactly.
Okay, so now let's talk about how they actually put R1 Searcher to the test. What kind of data did they use to train it? And how did they measure its success?
So for training, they used questions from two well-established data sets that focus on multi-hop reasoning, Hotpot QA and two wiki multi-hop QA.
Multi-hop meaning the questions require multiple steps or pieces of information to answer correctly.
Exactly, yeah. And they even categorized the questions in these data sets based on difficulty,
Mm.
easy, medium, and hard.
Based on what? How many steps were required to answer them?
Yeah, essentially.
Yeah.
They measured how many search and reasoning steps their initial model needed to arrive at the correct answer, and then used that to classify the question.
Okay, so they had a good mix of simple and complex questions to train the model on. And what about testing? How did they evaluate how well R1 Searcher actually performed?
Well, they tested it on 4 different multi-hop question answering data sets, Hotpot QA, and 2 wiki multi-hop QA, which they considered in-domain because the model had seen similar questions during training.
So those are kind of like the familiar territory tests.
Right, and then they also tested it on Music and Bamboogle, which are considered out of domain because the model had never seen questions from those data sets before.
So those were the real tests of how well the model could generalize its knowledge and skills to new situations.
Exactly, yeah. And they used 2 main metrics to evaluate the answers. Cover exact match, which just checks if the model's answer contains the correct answer, and then this more nuanced metric called LLM as judge.
Which basically uses another LLM, a really powerful one, to judge the correctness and quality of the answers.
Right, yeah. They use GPT-4o Mini for that, which is a really sophisticated closed source LLM. So it's like having an expert evaluate the model's work.
Okay, and they didn't just test R1 search in isolation, right? They compared it against a bunch of other existing RGAG approaches.
Yeah, they did a really comprehensive comparison against a whole range of baselines. This included just having the model generate answers without any search, standard RAG methods, those branching methods that explore multiple reasoning paths, summarization techniques that try to condense the retrieved information, adaptive retrieval methods that adjust their search strategies. are combined with step-by-step reasoning, techniques that refine their search at the very end, and even some really strong reasoning models that don't specifically focus on search.
Wow, that's a lot of different approaches.
Yeah, they really wanted to see how R1 searchers stacked up against the state of the art, and the results were really impressive.
Oh yeah, what did they find?
Well, when they used the Llama 3.18b instruct model as the base for R1 Searcher, it significantly outperformed Reader, which is a very strong existing method that actually uses that powerful GPT-4o mini model on Hotpot QA, 2Wiki Multi-Hop QA, and Bamboogle.
So even though it was using a smaller base model, our one searcher was able to achieve better results than a method that uses a much more powerful model.
Exactly, yeah. And the improvements were pretty significant. Like on Hotpot QA, it was about 48% better. On 2Wiki Multi-Hop QA, it was almost 22% better. And even on Bamboogle, which is that out-of-domain data set, it was still 4%
That's
better.
very impressive.
And get this, when they used the Quen 2.57b base model as the base for R1 Searcher, it actually did even better.
Wow, so an even smaller model.
Yeah, and it actually outperformed GPT-4 Mini on most of the data sets.
That's a huge win for this two-stage RL approach. It really shows how effective it can be at teaching LLMs how to search well.
Yeah, it's really exciting. It suggests that we might not need these massive resource-intensive models to achieve really good performance on these complex tasks.
That's great news for making this technology more accessible and efficient.
Exactly. And what's really promising is that R1 Searcher also showed strong generalization abilities. Well, remember how they tested it on those out-of-a-name data sets, Music and Bamboogle?
Right, the ones the model hadn't seen during training.
Yeah. Even though it was trained on a relatively specific set of questions, it was still able to do really well on those new data sets.
So it wasn't just memorizing patterns, it was actually learning something fundamental about how to search and reason effectively.
Exactly, yeah. And they even tested it with real-time online searches using the Google Web Search API, and it still performed really well.
So it wasn't just limited to the local knowledge base it was trained on, it could actually go out and find new information in the wild.
Right, yeah.
Okay, so they've shown that R1 Searcher can outperform existing RAG approaches, that it can achieve great results even with smaller base models, and that it can generalize to new situations. But the paper also goes into a lot of detail about the different design choices they made, right? Like the specific RL algorithms they used, how they designed the reward system, and the impact of the training data itself.
Oh, yeah, they did a lot of really interesting analysis to understand what makes R1 Searcher tick. Like, for example, they compared two different RL algorithms, GRPO and reinforce plus plus plus.
And they both work by reinforcing good behavior, right? But they have different ways of doing that.
Exactly, yeah. They have different mechanisms for updating the model's behavior based on the rewards and penalties it receives. And they found that GRPO seemed to generalize a bit better to that Bamboogle dataset, which is the one the model had never seen before.
Interesting. So GRPO might be better for handling completely new situations.
Yeah, possibly. And it also tended to generate longer answers and perform more searches. But Reinforce Plus Plus seemed to be a bit more efficient at learning from the data it was trained on.
So each algorithm has its own strengths and weaknesses.
Right. And they also did a direct comparison between training with RL and that supervised fine-tuning approach we talked about earlier.
Where the model has shown lots of examples of how to search and answer questions.
Right. And they found that RL consistently outperformed supervised fine-tuning, both in terms of accuracy and generalization.
So learning by doing, even without explicit examples, seems to be more effective.
Yeah, exactly. And their analysis suggested that while supervised fine-tuning could help the model generate search queries, it wasn't as good at figuring out when to search and how to use the retrieved information effectively.
So it might have learned the form of a search query, but not the substance.
Yeah, something like that.
And they also did some really interesting analysis of the reward system, right? Like how different ways of rewarding the model affected its performance.
Oh, yeah, the reward design was really crucial. They experimented with different ways of rewarding the model for getting the right answer.
Like just checking if the answer was exactly the same or if it contained the right information, or using that F1 score.
Right. And they found that using the F1 score as the reward led to much better overall performance than just checking for an exact match.
So rewarding the model for both completeness and conciseness led to better answers.
Exactly. And they also found that it was really important to be strict about rewarding the model for getting the format of the search queries and answers right.
Ah, so keeping things organized and well-structured.
Yeah. They found that without those strict format rewards, the model would sometimes do things like generate documents without actually searching or produce nonsensical output.
So those format rewards really helped guide the model toward useful and meaningful interactions with the search system.
Exactly.
And what about the training data itself? Did they find that things like the difficulty and diversity of the questions affected how well the model learned?
Oh, yeah, definitely. They found that training with a data set that included those harder questions, the ones that required more steps to answer, led to better overall performance.
So challenging the model during training led to better results.
Exactly. It's like pushing the model to develop those deeper reasoning and searching skills. And they also found that training on a mixture of questions from both Hotpot QA and 2Wiki led to better performance than training on each dataset separately.
So having a diverse range of training data is important.
Yeah, it helps the model learn to generalize to new situations. Interestingly, they found that training solely on the 2Wiki dataset, even though it led to higher rewards during training, actually resulted in worse overall performance.
So it's like the model became over-specialized. It got really good at answering those specific types of questions,
Hmm.
but it couldn't handle anything else.
Yeah, exactly. So it seems like having a good mix of different types of questions, including those challenging ones, is really key to getting the best performance out of R1 Searcher.
It's like a well-balanced diet for the AI brain.
Exactly, yeah.
And the paper also includes some really interesting case studies that illustrate how R1 Searcher works in practice, right?
Oh, yeah, they have some great examples. Like in one case study, they compared a model trained with RL to one trained with supervised fine tuning on a question about the last king of a particular dynasty. And the RL trained model was able to correctly break the question down into smaller parts, figure out what information it needed to find, and then use search to locate that information and answer the question correctly.
So it really showed off those independent research skills.
Yeah, exactly. And the model trained with supervised fine-tuning, even though it did perform a search, seemed to rely on some potentially incorrect information it had learned previously, which led to the wrong answer.
So it's too stuck in its old ways, whereas the RL trained model was able to adapt and find the right information.
Exactly, yeah.
Okay, so to wrap things up, what are the big takeaways from our deep dive into R1 Searcher? What makes it such a significant step forward in the world of R and LLMs?
I think the main takeaway is that this two-stage, outcome-based reinforcement learning approach is incredibly effective at teaching LLMs how to use external search as part of their reasoning process. And this leads to really impressive improvements in both accuracy and generalization.
So it's not just about giving LLMs access to more information, it's about teaching them how to effectively find and use that information.
Exactly, yeah. And the fact that it can outperform existing methods, even those that use much larger language models, is really exciting.
It suggests that we might be able to achieve much better performance with smaller, more efficient models, which is great news for making this technology more widely accessible.
Definitely.
And what are the implications of this research for you, our listener? What does it mean for the future of how we interact with AI and access information?
Well, I think it points towards a future where AI assistants can become much more reliable and trustworthy sources of information. They can become those research partners that help us dig deeper, find the answers we need, and make more informed decisions.
So it's not just about getting quick facts anymore. It's about having an AI that could actually help us learn and understand complex topics.
Exactly, yeah.
And as we wrap up this deep dive, here's a final thought-provoking question for you to ponder. We've seen how successful R1 Searcher has been in teaching LLMs how to search effectively. What other core capabilities of these AI systems could we significantly improve using similar, carefully crafted reinforcement learning techniques? What other skills could we teach them to master through this idea of rewarding good outcomes and encouraging independent exploration?
That's a great question, and it's something that the researchers themselves are actively exploring. They're looking at things like refining the training data selection process and scaling up the model to even larger sizes to see how far they can push this approach.
So the journey of making LLMs even smarter and more capable is far from over.
Definitely not. And approaches like R1 Searcher are paving the way for a really exciting future.
Well, thanks for joining us for this deep dive. We hope you found it insightful. Until next time.
Thanks for having me.